My name is K. Yashwant. I am from first year Triple E. Topic is characteristic of PN junction diode. Diagram of PN junction diode. Here anode, cath P is P connected with anode and N connected with cathode. Formation of PN junction diode. N-type semiconductor doped with pentavalent impurities form N-type semiconductor. Majority carriers are electrons. P-type semiconductors doped with trivalent impurities forms P-type semiconductor. Majority carriers are holes. A PN junction is formed when P-type and N-type semiconductors are joined methodologically. The boundary between P region and N region is called PN junction. In P region, holes are majority charge carriers and N region, electrons are majority carriers. This creates concentration gradient near the junction. Because of the concentration difference, holes nearer to the junction being diffused from P side to the N side. Similarly, the electron in the region are more than the electrons in the P region. Due to the concentration gradient, electrons near the junction begin to diffuse from N side to P side. Thus, majority carriers starts moving into opposite region. As electron and holes are charged particles, their motion produces electron diffuse current and holes diffusion current respectively. This motion of electrons from N region to P region and motion of holes from P region moves towards the N region produce diffusion current. At thermal equilibrium, the net diffusion current through the junction must be equal and opposite to the net drift current so that the total current is zero. This condition is called unbiased condition of the PN junction diode. Unbiased PN junction, when a PN junction diode is not connected with any external supply, is called as unbiased. Once equilibrium is attained, not a net current will flow through it because diffusion current becomes equal to drift current. Hence, diode is at equilibrium. The electrical field establishes potential difference V0 at the junction, which acts as a barrier for majority charge carriers to cross the junction. Biasing of PN junction diode. When DC voltage is applied to the diode, it is said to be biased. A PN junction diode is biased in two ways: forward biasing, reverse biasing. Forward bias characteristics: when P side is connected to the positive terminal and N type to the negative terminal. Forward biasing: when positive terminal of battery is connected to the P region and negative terminal of source battery is connected to the N region, the diode is said to be forward biased. If the external applied voltage V becomes greater than the value of the potential barrier V0, the potential barrier's opposition will be overcome. The width of depletion rail reduces. The potential barrier reduces by value V0 minus V. Reverse biasing: when negative terminal of battery is connected to the P region and positive source is connected to the N region, the diode is said to be reverse biased. The width of depletion increases. The potential barrier increases to V0 plus V. Hence, the majority charge carriers are unable to cross the junction. The direction of electric field supports the flow of majority charge carriers across the junction. Hence, a small amount of current flows. Graph of the PN junction diode across current versus voltage. The VA characteristic shown the relation between the voltage across the diode and the current in forward region. When the junction is forward biased, practically no current flows until the barrier voltage is overcome. With further increase in voltage, current starts the flowing at the curve as linear rise like an ordinary conductor. The voltage at which current starts flowing through the diode is known as cut-in voltage. It is minimum value of voltage required to overcome potential barrier across the junction. Reverse bias: when a junction is reverse biased, junction resistance increases with the increase in reverse biased voltage. Very small current flows it due to majority carriers. As reverse voltage increases, the majority charge carriers acquire sufficient kinetic energy. This accelerated charge carriers cross the junction and ionize the semiconductor atoms in the depletion region, leading to generation of free electrons and holes. These electrons and holes in turn get accelerated and cause further ionization of atoms. P, P and N region. This process is called avalanche breakdown and leads to sharp increase in current at reverse bias voltage called breakdown voltage. Thus, breakdown voltage is applied reverse voltage at which large current flows through the diode. In reverse bias condition, the current through diode is very small in range of microamperes due to movement of the majority carriers. Applications